Hello, my name is Talal Hamzi, and today I will be talking about metal foam. Metal foam has become a very popular term, which is nowadays used for almost any kind of metallic material which contain voids. Metal foams are being used a lot, but they haven't been used in every application they can be used at. Now, an introduction about metal foams. Metal foams is a cellular structure consisting of a solid metal with gas-filled pores comprising a large portion of the volume. The defining characteristics of metal foams is a high porosity. Metal foams typically retain some physical properties of their base material. Foam made from non-flammable metal remains non-flammable and can generally be recycled as the base material. Its coefficient of thermal expansions is similar while thermal conductivity is likely reduced. In metal foams, cells are divided into distinct cells. The boundaries of these materials are made of solid material. The interiors are voids. There are two types of metal foams: open cell metal foam and closed cell metal foam. In this slide, we'll be talking about the applications of open cell metal foams. Open cell metal foams are used in heat exchangers, such as combat electronics cooling, cryogen tanks, and PMC heat exchangers. Open cell metal foams are used in energy absorption and flow diffusion and lightweight optics. Extremely fine-scale metal foams are used as high-temperature filters in the chemical industry. And due to the high cost of the material, it is most typically used in advanced technology, aerospace, and manufacturing. Manufacturing of open cell. Open cell foams are manufactured by foundry or powdery metallurgy. In the powder method, space holders are used, and as their name suggests, they occupy the pore spaces and channels. In casting processes, foam is cast with an open-celled polyurethane foam skeleton. In this picture, we see an example of an open cell metal foam. The second type of metal foams is the closed cell metal foam. Closed cell metal foams are primarily used as an impact absorbing material. They are light and stiff and are frequently proposed as a lightweight structural material. However, they haven't been widely used for this purpose. Closed cell foams retain the fire resistant and recycling capability of other metallic foams, but add an ability to float in water. Foam metal has also begun to be used as an experimental prosthetic in animals. Manufacturing of the closed cell. It is manufactured by injecting a gas or mixing a foaming agent into molten metal. Melts can be formed by creating gas bubbles in the material. And normally, bubbles in molten metal are highly buoyant in the high-density liquid and rise quickly to the surface. The rise can be slowed by increasing the viscosity of the molten metal by adding ceramic powders or alloying elements to the foam, stabilizing particles in the melt. In this picture, we see a closed cell metal foam. And now we'll be talking about the applications of foam metal. For design, as metal foams can be used in product or architectural composition. Metal foams have mechanical applications, such as orthopedics, automotive, and energy absorption. And in the next slides, we'll be talking about each one individually. Orthopedics. Foam metals has been used in experimental animal prosthetics. In this application, a hole is drilled into the bone and the metal foam is inserted, letting the bone grow into the metal for a permanent junction. For orthopedic applications, tantalum or titanium foams are common for their tensile strength, corrosion resistance, and biocompatibility. Automotive. The primary functions of metallic foams in vehicles are to increase sound damping, reduce weight, and increase energy absorption in case of crashes. Compared to polymer foams in vehicles, metallic foams are stiffer, stronger, more energy absorbent, and resistant to fire and the weather adversities of UV light, humidity, and temperature variation. However, they are heavier, more expensive, and non-insulating. Energy absorption. Metal foams are used for stiffening a structure without increasing its mass. And for this application, metal foams are generally closed-pore and made of aluminum. Foam panels are glued to the aluminum plate to obtain a resistant composite sandwich locally, in the sheet thickness, and rigid along the length depending on the foam's thickness. The advantage of metal foams is that the reaction is constant, regardless the direction of the force. Foams have a plateau of stress after deformation that is constant for as much as 80% of the crushing. Thermal applications. Foams offer other thermophysical and mechanical features, such as the very low mass, as their density is between 5 to 25% of the bulk solid, depending on the manufacturing method. They have large exchange surface, which is between 250 and 10,000 meters squared. They have relatively high permeability and relatively high effective thermal conductivities. They are good resistant to thermal shocks, high pressure, high temperature, wear, and thermal cycling. They have good absorption of mechanical shock and sound, and their pore size and porosity can be controlled by the manufacturer. In this picture, we see a heat conduction in regular metal foam structure. Advantages of the metal foam. As discussed in the previous slides, metal foams provide excellent energy absorption features at a high strength level as compared to foamed polymers, especially in vehicles. Moreover, metal foams are easily processed by sawing, drilling, milling, etc. Metal foams can be joined by bonding, brazing, and TIG and laser welding techniques. It does not erode, even under the effects of airflow or vibration. It is easily recyclable, provides sound absorption at low frequencies at a smaller material thickness in comparison to other absorption material, such as glass or mineral wood, fibers, or polymer foams. Now moving on to the disadvantages of foam metals. They are difficult to manufacture as precision of manufacturing is required. Cost is a major factor in foam metals, as it is the biggest problem and the biggest disadvantage of foam metals. There's a difficulty in manufacturing high temperature metal. And as I stated before, the knowledge about metal foam is still not widely spread. And one of the biggest defects of metal foams is that once it's damaged, it cannot be repaired. So the whole metal foam has to be replaced by a new one, which is also expensive. Now I'll be talking about some suggestions that metal foam can be used at. And as we know, metal foams hasn't been widely used, but here are some applications we can use them in. First, in commercial lightweight doors. In the impact absorbing in cars. In lift safety systems. In road medians and dividers. In construction industry as a lightweight material. In shipping industries. Last but not least, in helmets. I hope this video was beneficial. Thank you.